Alright, first we're going to go over a multiple component system. Go ahead and pause the video now and read over the problem. Alright, so we'll start by following our BME problem solving methodology and assemble the problem. As it states, we want to find the mass of the calcium carbonate present in one of the pills being used. Our diagram is going to look like a box with two arrows going into it and one arrow going out. The arrows represent the streams going in and out of the mixing chamber, each of them with their respective weight fractions and mass flow rates. Next, we'll begin analyzing the problem. There is a mass entering and exiting the system, so it must be open, as well as that there is no mass being accumulated within the system, so we know that it's steady state. Lastly, there are no chemical reactions taking place, so the system is non-reactive. There's no extra data being needed to complete this problem, so we can move on to the givens found in the problem. The weight fraction for each component is given for the two inlet streams, and the weight fraction of the filler is given for the outlet stream. The basis for this problem is that the mass flow rate of the outlet stream is 700 grams per hour, and that it takes 6.05 seconds to make one pill. Now that we have all the variables defined, we can move on to setting up equations and calculating an answer. Since this is a math problem, we're going to want to use the mass accounting equation, which is mass in minus mass out plus mass generated minus mass consumed equal to the mass accumulated. But since we're working within an open, steady state, non-reactive system, we're going to be left with mass in minus mass out is equal to 0. Or in other words, the mass in is equal to the mass out in the system. To solve the problem, we need to use the weight fraction times mass flow rate accounting equation that can be found in the handout for class number 6. We will make a separate equation for each component, as you can see here. We're going to multiply the weight fraction for the specific stream times the mass flow rate for the specific stream. We'll be summing the streams 1 and 2 and subtracting the outlet stream, which is stream 3. And setting this all to 0 follows the simplified equation. As well as that, we need to write an equation that explicitly states that the mass flow rates of 1 and 2 minus the mass flow rate of 3 is all equal to 0. When we're using MathCAD, we're going to want to put all of these equations into the solve block or by doing matrix operations, as we have done here. We will find the 3 missing weight fractions for the third stream and the mass flow rates of the 2 inlet streams. Really, the only value that we need is the weight fraction of the active ingredient, which is 0.425. In MathCAD, the matrix operation is performed by the inverse of A times B, but in MATLAB, it is A backslash B, so we'll show that shortly. With these values, we can calculate the mass of calcium carbonate found in one pill. We want to use the value of the weight fraction for the active ingredient in the outlet stream and multiply that by the mass flow rate for the outlet stream. And once we've done that, we're going to multiply it by the time it takes to make one pill, which is 6.05, and we'll get the mass of calcium carbonate found in one pill. To finalize this problem, we'll state that the mass found in one pill is 0.5 grams. From here, we're going to continue on with this problem in the second part of the video, which can be found in the link in the description. First, we'll show you the code for MATLAB. You can pause here if you want to go over it.